Değerli konuklar.
Well, ladies and gentlemen, welcome to the session. We're honored to host you in the 7th Turkish Wind Energy Congress. I would like to start off the very last session of the Congress. As of July 2018, the Turkish Association for Wind Energy has disclosed that we have an installed capacity of 7,000 megawatts currently. We will be hosting distinguished representatives of offices of global companies in Turkey. I think this session is going to be a big opportunity for all of us. Hopefully, at the end of the session, we'll have time spared for questions and answers. In this session, we'll be discussing where the new generation wind turbines are going. Before we start the discussion, I would like to lay the ground with a few questions. During the presentation of your product portfolio, please be kind to speak about your differences from other technologies, plus any information you may have about offshore products, if any, in your product range. And I would be very glad if you can share some information about smart technologies. If I may, I would like to start with Sermin Eren from Siemens Gamesa, Commercial Sales Manager. As you know, Siemens, as of July 2018, reached 830 megawatts, and this is your turn.
Merhaba herkese.
Hello, everyone. First, I hope you've had a very efficient Congress altogether, and I do hope that it's going to be a fruitful session. My name is Sermin Eren. I am the Commercial Sales Manager for Siemens Gamesa. This is my presentation that I prepared for you. This is the outline. First, I will give you some information about the company profile briefly, because as you know, Siemens Gamesa has been recently merged. Therefore, we do get a lot of questions about the merger. I will start with some merger information. Unfortunately, the presentation concentrates only on onshore business, and I will give you some information about the product portfolio and new technologies, plus I will end with operational excellence. As for the corporate profile, Siemens Gamesa was created in April 2017, last year, as two distinct companies, the Siemens and Gamesa, joining their innovative spirit, dedication to technology, and determination to provide real and lasting value to stakeholders. With this creation, it's been heading towards a leading position in the sector. Actually, when you take a look at the history of each company, Gamesa was a small company that was established in Spain, but started quickly to be present in new and innovative markets and taken a big leap forward in a very short period of time, has been quite successful. And United States, China, India were also added in the scale of worldwide production centers. And we can say Siemens Wind Power also has a very impressive history as well. Once Danish Bonus Energy was acquired by Siemens when it started to work on the wind power. Therefore, Siemens was also a leading company in the offshore field. These together actually has reached this capacity on the screen. Onshore, offshore, in total 87 gigawatts of globally installed capacity present. We have almost 75,000 employees. Also, we have 11.5 gigawatts of order entry, which will be added on top of over the next years. Now, this is the ownership structure because people ask questions about the ownership structure. It's a merger. 59% of a share by Siemens, 8% by Iberdrola, and 33% free float shares. And it's been listed in the Spanish stock exchange. Now, 87 gigawatts, how to distribute onshore, offshore, and services. Onshore, 75 gigawatts of an installed capacity in 75 countries, and 10 gigawatts totally developed by Siemens Gamesa in 14 countries with its wind farms. In offshore, 11.9 gigawatts of installed capacity, and service 56.6 gigawatts. Now, concentrating on offshore, you would see that out of 75,126 megawatts distributed in 75 countries, you can say that 47 gigawatts is under an O&M. Geographic distribution. Asia Pacific countries 9%, India 7.4%, North Europe and Middle East 18.3%, Southeast and Africa 27.2%, North America 28.6%, and Latin America 9% of a distributed share. Let's move on briefly to the product portfolio. Together with the two companies merging, of course, the portfolio of products diversified very much, but mostly the concentration is on the 2, 3, and 4 megawatts of geared technology turbine segments, plus Siemens Gamesa onshore direct drive can still be offered. Now, as you can see, low, moderate to high-speed turbines is a classification, and you would see that covering all the ranges, we have a wide product portfolio. And as Siemens Gamesa, in the long run, we will mostly concentrate in promotion of mostly geared technology, but in some markets we can still provide direct drive technology. Now, of course, we have legacy products coming from the companies separately. As you know, Gamesa used to have 2 megawatts of platform installed a lot in Turkey. They are still there. I mean, they are being used whenever necessary, can always be offered. And 5 megawatts of turbine the same. And Siemens also has the geared onshore platform, 2 megawatts, and also has direct drive, 3 megawatts platforms can be offered in favorable sites in good prices still. This is the state-of-the-art technology that we've developed. As you can see, product portfolio in line with technology and know-how of the two companies. We really have a diversified product range. OptimaFlex technology aims at providing more services to more coverage. In other words, we want these products to be tailored to the specific needs of different fields with the OptimaFlex technology. But what is OptimaFlex then? Can be summarized as follows. Beyond the traditional off-the-peg approach, we want to provide the customized offer for the field of our customers. Here, we do optimized site design, combined with a diversified product range, lowering capex as much as possible, providing the most favorable product to the field. In other words, we want to provide levelized cost of energy. How do we do that? Firstly, with our stakeholder, with the customer, we get into a close collaboration, get into the details of the field. If necessary, work on the layout, and we design the turbine according to the field. We shape the characteristics accordingly. And then once we offer the product, we install, and nothing is finished there, we provide a real-time monitorization of the turbine data by making the necessary unnecessary optimizations thanks to our software. Therefore, we aim at improving the efficiency of the turbine, reducing the OPEX cost, finally targeting productivity. There are 5 pillars. The first one is flexible rating to improve power output. In other words, to have a tailored design to the field. I will get into the details of these pillars one by one. The second is advanced site optimization, another site-specific tower portfolio, and BOP optimization. Last but not least, lifetime extension of the turbine. Let's go through each of these one by one. Flexible rating. Flexible rating is essentially to improve the output power of the turbine in consideration of the environmental factors, the requirements of the project. In other words, we are designing a turbine, but there are several variations to it. And then there is a control software that we make to guarantee the lowest energy cost for the project. With this software, of course, the aim is to have a real-time configuration of the operational parameters, improving the optimal performance. This can happen through, number one, a turbine within our product portfolio will have different implementation or application modes. These application modes are distinct, considered as a standalone turbine supported by technical documentation and type certificates. But actually, these distinct application modes will have the specific output powers, wind conditions, and ambient temperatures, reactive power capabilities, and aerodynamic noise levels, as I will show you in this example. Like this is 4.5 megawatts, SG 4.5145 turbine. You can see the mid baseline is the one in the midline. But we can have variations in different application modes according to the type of the wind. In this way, we consider very different reactive power modes, so we can get 7 turbines out of 1 turbine. The aim is to cover a variety of fields and to offer the best fitting turbine to these fields, maximizing energy production, lowering turbine costs, and this way we want to lower the unit price of the energy. OptimaFlex is another pillar, another feature, advanced site optimization. Now, about this aspect, as you know, every site will have its specific wind requirements. In some sites, which may be a big concern in Turkey, but on a global scale in many countries, there are noise limitations and also tip height restrictions, flickering requirements. These kind of parameters would make each site specific to itself, so it would be a tailored project for each site. As Siemens, for the turbine locations, we want to support our stakeholder, resulting in the maximum energy producible layout. This is how we do with the advanced tool attend. Another aspect is site-specific tower portfolio. We previously make a pre-designed tower portfolio. Now, every turbine would have variety of turbine alternatives. According to these alternatives, and as you know, the tower is extremely important because so as to optimize energy. According to wind data, you have to go up. Sometimes we have to design a moderate level of a tower. In these cases, Siemens Gamesa's portfolio is quite large because we have previously designed, tower projects, and we can design other things specific to the site, still hybrid or concrete towers may be offered. And in this way, we're aiming at lowering the tower cost plus the delta energy production optimization in our offering. Another thing is BOP optimization. BOP is actually almost 25 to 30% of the total cost of project. Therefore, Siemens Gamesa, although it may not be in its own coverage, also supports the stakeholders in terms of BOP optimization. Thanks to the engineering tools and our engineers, of course, we can provide significant optimizations on BOP. In this respect, for projects with a project volume beyond 15 units or in complex ground conditions, we may be supporting our stakeholders, particularly on BOP optimization. Another bullet point is operational excellence. Here there are 5 different programs that we do offer within the framework of O&M profitability. OptimaFlex technology brought some innovations in terms of O&M service coverage. Number one, we do have variety of software for life extension, particularly when the turbine is in operation. The loads that the turbine has to bear will have to be flexible with several software. And thanks to the works that we are doing, we can extend the service life of a turbine up to 10 years. The second package is other OEM turbines upgrade. Meaning the turbines, in the fields where the turbines of other manufacturers are installed, let's say an old turbine, even if it's a different manufacturer, we can upgrade that turbine to improve energy production up to 10%. Like, for instance, V47 turbines can be converted into G47 with a trigger of energy production by 10%. Third package is energy thrust and power boost, meaning maintenance and repair works plus software support for the previous, our own turbines that were installed in the past. With this way, we can go up to 25% of energy production. Another package is we can provide O&M services in the sites of different turbine brands or manufacturers. O&M is extremely important to us, and in the world, it's been extended as a network in different parts of the globe. And as much as we can, we should also improve our know-how for the other turbines of other manufacturers so we can deliver O&M service commitment and offer in other fields as well. The last program is digitalization and cybersecurity. Digitalization really is an important aspect of today's agenda. As Siemens Gamesa, we've been providing services about digitalization as well. Therefore, thanks to the software of digitalization, we have and we may conclude a lot of improvement in turbine technology, both in terms of OPEX costs and lowering the OPEX costs and the applications. We have taken significant improvements.
Evet, teşekkür ediyorum.
Thank you.
Selmin Hanım, çok teşekkür ediyoruz.
Thank you. And you mentioned about the product portfolio and the new technologies, OptimaFlex, operational excellence, and also offering different maintenance services to turbines. So with regards to cybersecurity and all, thank you. If you allow me, second speaker. From Nordex, Yusuf Gökalp, Nordex Aksiona, sales engineer. Nordex in July 2018 as of, and over 1,800 megawatts that they have, and they have quite a good market share. Yes, please. Thank you. Hello, everyone. Welcome. Very briefly, I will introduce myself. In 2016, graduated from engineering, energy systems engineering, Istanbul Bilgi University. I'm having my master's degree. I joined Nordex in 2015. I was assistant site manager initially. After 9 months in total, I've installed 20 turbines. and as of February to completed the development, and next year we will have the prototype. It is 4.8 megawatts, and it's pure IEC1. With the previous Delta version, what is the difference? I mean, from Delta to Delta 4000, what we did so far. Of course, in the Delta generation, 131, that was the rotor diameter, now 149 meters, so 74.5 meters of the blade. Of course, we have more loads, and therefore the weight of the components are more. It increased the load on the turbines, and we now have enforced pitch bearing to handle loads. And another thing we did, the major change, the transformer and the converter is in nacelle. In the Nordex, the transformer and the converter was inside the tower. And the reason was that there's actually increasing rotor diameter and the height of the towers also increased. So low voltage cables 21 in Nordex increased the cost a lot. The transformer and converter is in nacelle now, so we get rid of these costs. I mean, the common denominator is actually the cost of energy to reduce per unit, so that's actually quite a good leverage. As I told you, several main components in the nacelle stronger. By saying power, I mean especially the components. We have M4 structural components, especially at the O&M level. We actually succeed in reducing the costs, which I will discuss later in detail. And in the Delta generation, outer nacelle dimensions remain unchanged. The main goal in here is actually have no transport issues, and the previous session discussed about transportation challenges, so we have one-to-one. And updated yaw system, maybe major change in the turbine. In the Nordex turbine, there's actually the calipers, the tins of calipers per brake, and we removed the system, and rather than that, we have the yaw system. 4 yaw motors now increased to 6, and with the motor brake, that there will be the brake. So this actually reduced the cost a lot. Another change, again, it's actually reducing the costs with a slight change. And of course, we now actually have optimized towers with less internals. Again, transformer and converters in the nacelle, so especially we have less number of components inside the tower. The cable is just one single cable from top to bottom, and the components, it's actually, we don't have any components attached to this, so a severe steady decrease in tower cost. N133, I mean the difference between 149 and 121. I'll not get into the details, but very actually small changes. That's the exact copy of the previous slide, but all is also the same in N149, but in the blade 65.5 taken and adopted to this turbine, I mean installed directly. I mean the rotor diameter 133, so N149 actually put a smaller blade, so more power. And thanks to this turbine in IEC1 class, the strongest. And of course, as you would appreciate, we actually have a new tower portfolio. In Nordex, we always make this comparison. Think about the side K parameter, A parameter, and for the side, we install Nordex turbines one by one. Okay, we develop it, but what is the gain out of it? N117, 3600, N131, 3.6, 4.8 megawatts. Once simulated, between N117 and N133, 4.8, 51% of the difference in annual production is quite big. I mean, if you want to increase the annual generation and reduce unit costs, actually that is the most important. I mean, you have to be able to increase the annual generation. So this formula is actually something so important for the entire turbine industry. That is the cost of energy. Your CAPEX, I mean your initial cost, OPEX, operational expenditures, divided by the annual energy production lifetime of a turbine. It makes the cost of energy. So if you have less on the top of the line and more under the line, it means that you will reduce the COE. And a couple of things to mention in here. Now, the turbine design, just as the case in all turbine manufacturers, in each generation, by changing the design or by some slight modifications, we're trying to reduce the capex. In Delta 4000, by bringing the transformer into the nacelle, changing the brake systems, we succeed in doing so. Of course, you should never compromise from quality. You have to preserve quality, even you have to further enhance the quality and at the same time reduce the cost. In Delta 4000, so generator power is high, so in annual production for lifetime, production increased significantly. For OPEX, that is the serviceability, the cost, the operating expenditures. In the previous Delta generation and Delta 4000, the service costs reduced by 30%. It's a huge number from our perspective. At the same time, you cannot see it properly, but it is minus 25%. That is the time that service technicians should spend in one turbine. For example, the gearbox will be changed. In the Delta, actually 12 work time, it is 7.5 in Delta 4000, so 25% of a reduction, saving in time. So, these are the topics that we discussed over the project. I don't want to take too much of your time, but just the logic behind it that I will discuss. Nordex specific to each side. Now, normally, it is 20 years as the life cycle of the turbines. We can increase it up to 25 years. And it is certified. I mean, an independent certification authority from TWEC. It will be offered to a project or extended soft cutout. For the bringing wind velocity to a further position and load optimized power curves. How this works? If the turbine allows for the load, then this at the power curve side, I mean, it's possible to have an increase in some of the projects, and especially if the frequency of the wind power is high, then it can contribute to the annual production. On the left side, design, that's the design parameters of the turbines. Again, you can see wind shear, air density, and current, we consider them. On the right side, that is the site. We have your project and we assess the parameters, and these are the parameters of your own site. Once this is the case, the power curve will be kept the same. Let's not change it. We can actually we apply more force on this turbine, especially for the main components. With the load-bearing components, we push it harder, and so we can have the life cycle for 25 years. It is the same for the others. I mean, now, on the slide, it's a brief summary, not brief, of course, but I will make it brief, but how we are doing. In the certification process with TWEC, for the main load-bearing components, we ask for a certain study. For example, the hubs, again, bolts, the blade bolts, and we make a calculation. For example, the blade bolts can last for 20 years, 15 years. And then if we can push it further, and with TWEC, we actually end up with something like this. For example, the blade bolts, as you can see, 22 years, the lifetime given. What you're saying is, let's mention it in the report, after 22 years, we need to change the blade bolts, but we'll keep it on the site for 25 years. And we will do it with the certificate taken from TÜV Nord, an independent authority. So, and of course, there is the need for service provision to the turbine. We provide you with the documents, and the document certificate taken from TÜV will be given to us, not only for load-bearing components, also for the auxiliary systems like anemometers, the hydraulics inside the turbine, also separate studies and reports issued for them. But the main thing about 25 years is especially for the load-bearing components. I don't want to take too much of your time, but here is a nice case. I'll share it with you. So, two business cases. In Delta 4000, so at different modes we can operate it. In the middle, you can see, now you start operating the turbine. It's not 4.5, but 4,380 that we offer. But in several projects in Turkey, it's the TWEC. So we, for example, have to sell it over a price initially. So in the first 10 years or in the first 12 years to the turbines, let's work them under 4.5, I mean over the load. But during that period of time, you can make the money, because it is $7.3% you should get it, and for maximum effect for the business case to this time, with the maximum power that we operate the turbines. By the end of year 10 or 12, to the turbines, if it is 4,380, then we reduce it down to 4,300. But for maximum benefit, it is possible to apply it to the Nordex turbines. So N149 is now installed as a prototype in Germany. So initially last year, 2017, September, that we announced that we will have such a turbine. This year in August, we have the public release of the prototype in one site. 1 month later, the design certificate received. In the second quarter of 2019, we'll start serial production. And up to September 2019, we're planning to get the type certification. So that is actually a nice approach that we have. We always keep our promises. So from PowerPoint to power plant in 18 months. I mean, we delivered the first PowerPoint presentation 18 months ago, and on the power plant in 18 months. And as promised, more than 20% of a benefit and double-digit CO reduction. I mean, between 10-15% of a benefit again for the investors. So I have a video. Prototype of N149 from our site in Germany.
teşekkür ederim.
Thank you for your attention.
Yusuf Bey, çok teşekkür ederim.
Thank you, Yusuf.
18 ayda
In 18 months from PowerPoint to power plant. So,
gerçekten satış
and in terms of sales in the market share, I think it is actually the Delta generation platform that gives you a success. And now you have the new Delta 4000 on the top of your success. So I think only for example, the blade length, and rather than the increase in the power motor, and also the transformer included in the nacelle and the converter. Also, you mentioned about a 30% of a reduction in the service cost. For myself, it's actually attracting my attention. So some of the important changes. Now, third speaker from Vestas, Abdullah Görür. Abdullah in Vestas, technical bid manager. And Vestas now is 1,570 megawatts, so 22% of the market share that they have. Yes, Abdullah.
Thank you, ladies and gentlemen, and welcome to the session. I know it's the last session, and a long list of participants, so I will try to be brief in explaining you where the new generation wind turbines are going to. Rather than a classical answer, I will try to get into the reasons. And I'm here on behalf of Vestas Technology as the technology team. We are in charge of all kinds of feasibility works regarding the project, and I am representing my team in this presentation, as discussed by the previous speakers and as will be discussed by the rest. We all aim at fulfilling three main functions: investor, financer or fund provider or technical consultant, and suppliers and regulatory authorities. These three functions all aim at achieving levelized cost of energy. I want to talk about it because the new generation turbines, where and why they're going to that direction, I think this start of a statement is important, because on to this statement we should be discussing which platforms and portfolios we should be basing ourselves. Briefly, in 79 countries, we can see that we have two really major company. In the current portfolio, I'm emphasizing this is what we have today, is 2 and 4 megawatt platforms in two different ranges. The aim there is 2 megawatts is preferred for fields with a megawatt limitation, 4 with the PET limitation, and in our country generally high capacity turbines are in installation, but in America or Asia, mostly 2 megawatt range turbines are being preferred in these markets. Therefore, 2 megawatt platform, and I will not speak about it too much, but historically speaking, I mean, there are some milestones in the evolution of these platforms. You can see from 2000 up until today, the turbines have undergone some kind of transformation. I mean, answering the question of where the turbines are heading, I think we have to understand there is an accelerated process. As for the 4 megawatt platform, you can see this is an evolution of the 4 megawatt turbines. You can see there are different blade diameters, heights, and sizes that the 4 megawatt portfolio is serving. Actually, this is important because Vestas has been serving in different places of the globe. Therefore, the different type of turbines can be positioned in different ways. For instance, you will never speak about V105 in Turkey, but when there is an upper limitation in an island in Greek, we can use it, like V90. It has been a part of the consent authorization processes in France, and they've used this product in several sites in France. So discussing where the new generation turbines are heading, of course, you can see in the gray areas where the turbines can be used. Used meaning the new generation turbines also going beyond the IEC standards. They're customized to the needs of the project site. As previously discussed by my colleagues in the panel, we're also designing as a customized approach. Now you can see the 4 megawatt platform evolution. In 2017, V117, 136, 150, and even higher power modes were developed in a site-specific way. So now we can deliver customized solutions for these as well. As again for 4 megawatts, we have more than 4,000 turbines installed in 34 countries. I mean the evolved version of 4 megawatt. Last but not least, in the current portfolio, you can see the distribution of the design of the 4 megawatts. For instance, class 1 and extreme site conditions were considered, probably in countries like Japan, where the typhoon events are quite common. V150 wouldn't fit the needs of Turkey, whereas 136 and 117 would rather meet the expectations in Turkey. Of course, turbines undergo an evolution in time. This is the very first curve of power, the orange one, and the blue you can see is V15, and the orange one is V112. Especially in the area of high wind capture, you can see that the evolution has been quite remarkable. V136, as for its historical evolution, its sweep area seems to be the most important criteria. In other aspects, noise requirement and limitations, you can see, is quite important for this, especially in countries like France, where there are noise limitations. It becomes more important. On the left side, in the rectangular one, you can see the design next to the gray areas, which is the applicability of the turbines. Like in A78 turbulences, you can see may also fit the conditions of the site. Particularly recently, this would answer the question as to where the new turbines are heading, because sometimes investors say the field has a wind of 9.6 and how the turbine would fit that site. But of course, we consider all the load and design parameters, and we would just end up in meeting IEC standards of the usability of a given turbine in a given site. Again, V15042 version has up to 22% of a swept area. Again, as for the siteability of the turbine, you can see how flexible the turbine would be. This really is an important note. But this is the current portfolio, but the new generation still keeps on developing, and the 2-year interval will have to get shorter due to, known reasons. Let me speak briefly about this aspect, because as you know, the sector is based on feed-in tariff, feed-in premium or YEKTEM mechanism in Turkey. And there is a process of tender. Therefore, in these processes, the new generation turbines are not taken from the current shelf of products, but with the products under design. New generation turbines have to be considered in this respect. The suppliers, public authorities, because sometimes, as one of our colleagues said, they want to get the turbine now, but will be a reality in 18 months. The same is true for many other companies, so the type certificates will have to be considered in this respect. This slide is, emphasizing the versatility. There are project-specific technologies. Extension lifetime from 20 to 25 years, or site-specific tower that will be a site-specific tower design. I think Brazil is a good example. The micro distribution was at the point of 3.5 to 4, and the extreme wind capacity wouldn't exceed 4.5, for instance. IEC Class 1A tower being installed wouldn't make a sense there. Therefore, the tendering processes of that country, by the way, they've gone a very severe, very remarkable process recently. The site-specific turbine design is to be presented for that site. Again, another aspect is versatility for tower optimization or for foundations. This again covers the site-specific aspect, making the project even more feasible. This is the timing of the 4 megawatt platform, and similarly you can see V150 installation. And also the next year, through the end of the next year, type certification will have been complete. Last but not least, I would like to speak about hybrid power plant solutions. Vestas has also hybrid solutions. Kennedy Energy Park is in Queensland state in Australia, and has been the first pilot project, full integrated wind, solar and storage system all together working as a first time. The nice side of the project is that the climate conditions of Australia requires project-specific approach, because during daytime solar irradiation is quite high, whereas at the night time the area receives high amount of wind. So 24/7 there is the need for a stable electricity flow, both from solar and wind, and whenever there is excess, storage will come and play, or upon the needs of the investor, of course, and upon, of course, their way of supplying to the energy market, they can make use of the advantages of storage in the system. Where the new generation turbines going, power plant controller by Vestas. It's a software, IKEP. Both can also control the solar panel and storage systems, and the main drive is wind control, and this way it will be providing a more stable, a smoother energy output into the grid. Now, this technology, once again, I'm repeating, as I said at the output, the three functions, a regulator, PPAs, long contracts, and at the same time, the field or climate conditions in the site. These all three pillars will contribute to technical solutions, I do believe. Thank you, and that is the end of my presentation.
Abdullah Bey, çok teşekkür ediyoruz.
Thank you, Abdullah.
Yıllarda 3-4 megawatt
Especially, it was,
portföyün artık
ve
üzerine doğru
4 and over product portfolio that you have. And Abdullah shared 4 megawatt platform, the design criteria, and also the characteristics.
ayrıca Avustralya'dan bir
Also from Australia, a hybrid power plant that he shared with us. Quite a nice case.
bu santralde bence
I think in that power plant, I can say it shows the power of the renewables and how important it is to have a hybrid approach. Thank you again. Now we'll move to the fourth speaker. From Enercon, Volkan Özer, sales manager at Enercon.
Enercon şu an Türkiye'de
Enercon right now in Turkey is 1,341 megawatts, 19% of the market share.
devam ediyor.
Yes, the floor is yours.
Teşekkürler.
Thank you, Aydın. Welcome, everyone.
Bugün kısaca ajandayı üzerine
Well, for the outline, general information on Enercon, then the turbine technology and the product portfolio very briefly, and then about our service.
öncelikle
So,
Enercon'un
For Enercon, at the global structure,
Yani Eylül 2018 sonu
by the end of September 2018, 49.9 over 49.9 gigawatt installed capacity,
şu an işletmede olan
and over 29,000 turbines in operation. Of course, we have production facilities worldwide. Turkey, we also have the blade factory in Izmir, again, concrete and tower.
genelinde 369'un üzerinde servis
Over
istasyonu,
369 service stations that we have.
iş konusu rüzgar türbini.
It is the wind turbine technology mainly. But besides that, in Germany, also to the north, there's operation electric transmission and railway transport.
Kendi tasarımı olan, %100 kendi tasarımı olan
And also with the, again, e-ship, transport ship that we have.
güncel konulardan
And of course, storage, which is a hot topic. Also e-charger, the R&D department is working on this, and prototype as well.
bunun üzerinde tesise ihracat.
Over 40 countries we have export.
Türkiye'deki yapılanması
So, looking at Enercon, the administrative office is in Istanbul, Ataşehir,
İzmir,
and in Izmir, Bayraklı, again we have an administrative office, again for project management, finance, logistics.
İzmir, Çiğli'de 1999
Again, in 1999, in Izmir, in 8 different regions, we offer services, and over 250 at the same time. Again, rotor blades in 2002 it's been established, and 3.8 gigawatt again of a capacity that we have as the production. 30% again internal market, 70% export mainly. WEC Kule, WEC Tower, founded in 2009. 153 precast concrete towers totally produced, 100% serving to the local market.
türbin teknolojisine baktığımızda
Turbine technology,
geçtiğimiz senenin sonlarına doğru büyük
by the end of last year, probably you know it from the social media, Enercon, again, a direct drive turbine technology producer with Lagerwey, purchased the sales from the Netherlands, and the Lagerwey platform, LP4, LP2 included in our portfolio. For the time being, it is again LP4, 136, 147, and 100 that mainly L100 that we offer. Of course, because of the local content, it's Enercon platforms again offered locally, but Lagerwey again is
yurt dışından gelecek şekilde.
will totally be imported
Bununla birlikte
to offer to the investors, and also L160 LP4 of Lagerwey, and Enercon, if you know from the social media, the copper coils, and from copper coils we have aluminum coils now transformed. It started with EP3, and
Bunun devamı olarak da 138 EP3
and in 138 EP3 together with L160, it's now under development by the R&D department.
tabii
Of course, in the EP3 series,
şen parça jeneratör ve
it is actually the
istatördeki bakır sarılardan alüminyum
so from the copper to aluminum. And of course, design optimization is not only limited to this. We have a new nacelle, more compact now.
elektriksel elektronik
For
altyapıdaki
electric and electronic control system improvement, and also single piece
ciddi dizayn
production, no spoiler use. So we have good design optimization.
jeneratördeki
As you can see,
alüminyum sahibi işe baktığımızda
form round aluminum coils they are used in the stator. Of course, it helps for better cooling. For the aluminum has such an advantage. Of course, easier automation that we have. Besides that, maybe most important thing is that as you move from copper to aluminum, in terms of tone, much you have an advantage, of course, cost optimization as
Burada
well.
göreceğiniz üzere aslında bu EP3
As you can see,
sitesindeki
again,
E126
EP4, EP3 comparison. As you can see,
457 ton olan
457 tons of the tower head
6 tonlar
reduced down to 256 tons thanks to the design optimization.
burada isterseniz E126
Here you can see
E126
E126 EP3, the prototype
18 ayında
by August that we install it. Let's share the video together.
E126 EP3 serisi
In EP3, E126 can be offered in 3 different towers, and the steel, the tower, and also hybrid tower of different heights.
EP3 serisi
EP3,
yerli kule, kanat,
that's the local tower,
üretimciler
also blade generator
sunulmakta.
offered to the investors.
Jeneratör hem
The generator
hem de lojistik anlamda kolaylık sağlaması için
for logistics, again, ease of logistics and generation, it's actually transported and installed in pieces, 9.5 meters of diameter, and for this series, E126.
Enerkon türbinlerinde
In Enercon turbines,
sistemi
the inverter, again, transformers are at the base of the turbine.
türbünün
126 turbine, the life cycle is 25 years.
klasik bir türbün. Klasik
A class 2 side turbine.
Bu sene sonu itibariyle seri
By the end of this year, the serial productions will start.
kanatlar tek parça olarak monte
The
ediliyor.
rotors can be installed in single piece, but of course the project department should actually assess it also in star form. It's possible to install it.
Evet. Bunun devamı olarak E138 EP3 serisi.
E138 EP3, 3.5 megawatt nominal power.
81 metre, 111 metre çelik.
Again, 81 cell tower, and also we have hybrid solutions for hot heights. Service life 25 years for class 3.
Elektronik inverter tasarımı,
There's
kontrol
electronic inverter design
sistemi optimizasyonundan da
and the control system optimization that I discussed about. Of course, it's much more compact than a cell, and also from passive filter to active filter, both electronically.
daha az yer,
And of course, it occupies less space and less cost as well.
katkı sağlamış.
So it all contributes thanks to the design optimization.
E138, EP3 ve
E138,
115 türbünüyle
again,
kıyasladığımızda
comparing to 115,
126 türbünü %12 ile %30
126 between 12 and 13% of an increase in power. When compared to 115, again 20 or 24% of an increase in yield.
Bahsettiğim gibi Lagardère
As I told you, after merger with Lagardère, of course, in both turbine technologies,
kullandığı çözümlerle
there are different solutions offered. MSD tower, modular steel tower technology of Lagardère, climbing crane option.
Çalışmada B100 türbünü 2 megawatt
For 2 megawatt turbines, it's possible now, but R&D department is working on it. Both adaptation of the Lagardère to Enercon to Lagardère, and also vice versa for mutual adaptation. R&D works continue. The Lagardère's climbing crane and also about the tower installation. per the video.
3 tırla sahaya.
So transport is only by 3 trucks of the climbing crane. If the climate is available, then 1 day installation. So with the climbing crane, a full set can be installed. So direct drive technology by Lagavre, but permanent magnet again technology used. L147, 4.3 megawatts nominal power, 147 rotor diameter, 2 different hub heights, 126, 155, again MSC tower. Lagavre turbines, design lifetime 20 years. In the prototype, in the last quarter of 2018, it will be installed and serial production will start by 2019. That is. So, the service now. It is actually EPK, Energy Partner Concept, that's our service contract, and it is EPK1 that we offer to the industries in Turkey. So all troubleshooting, remote monitoring, and spare parts, repair and replacement of major components, transportation. So it's a full scope service and including availability guarantee. EPK 2 and 3 is mainly used in the German market. Again, crane and special transportation sometimes they get it. And also about the major components. So we can help them. So Enercon service stations, so over 6,000 service employees, over 369 service stations worldwide. Thank you for your attention. Thank you very much, Volkan. And especially we have all these mergers and acquisitions within the industry and about Enercon's merger with Lagavre. Thank you for that, especially climbing crane technology, and especially if the, of course, weather conditions allow. I mean, the turbine installation is not 1 day. I mean, the tower is installed in 1 day. Okay. Of course, at the Enercon side, maybe one of the major changes, you shift from copper to aluminum. Therefore, for cooling and automation, especially, it actually helps a lot. So thank you very much. So fifth speaker from GE, Senior Product Manager, Halet Klabi. As you all know, GE actually over 1,230 megawatts and 18% of the market share that they have in Turkey.
Thank you very much. I'll be the only English speaker. Sorry for that. So I'll try to speak slowly so everybody understands. I'll not talk about product basically because it's not the topic of this session. I'll talk more about technology and how GE is investing a lot of innovation and technology to change the rule of the game in the wind energy producing. So basically, at GE, we are innovating daily to bring the cost of energy down. This is our main motivation. I joined GE 2 years ago, and previous to that, I was working for a developer, and also I work for a technical advisor. So I'm in the wind industry for more than 15 years. Let's say there is two evidence today. We need to bring down the cost of energy to compete with other sources. I'll not talk about climate changes and the fact that renewable energy is green, and all this is obvious to us, I think. And the second dilemma is a lot of windy locations are gone. In fact, we remains with a lot of class 2, class 3 sites. So that's why innovation here is really, innovation technology is really a key game-changing, and GE, by its latest product, really trying to reinvent the game with technology. So basically the market is changing. When I started working in renewable energy, the biggest turbine was 77-meter rotor diameter. Today, GE have the biggest turbine, which is 158-meter rotor diameter. That's 77. It's a completely different world, and technology here is really changing the game. We have a nice French word saying is technology is the Santa Cruz of the economist. So basically, economists can do a lot of calculation on how to reduce the cost, but by having the right technology, we can change the step, can change the game. So when we design turbine, basically GE, we focus on 3 points. Mainly how to lower the cost of energy, so increase the energy production, reducing the price of turbine, and reducing the OPEX, of course. That's the main 3 points. The second point is how to have a flexible and evolutive platform. Typically, that means that we want to design turbine platform that can go to a lot of site conditions, mainly class 2 and class 3. So we build our platform to be evolutive. And the third point is we want to offer an improved serviceability and performance. So it's all about this LCOE trilemma, which is the OPEX, the CAPEX, and the AEP. So probably 5 years ago, we were offering the 1.7 turbine. It's a 103 rotor diameter. It was a perfect turbine. Everyone was happy with this turbine. We sold many of them. Simply today, we are offering a much bigger turbine, which is generating 160% more energy. And this was possible by technology. So I'll probably have one slide on product. So, how to change it? Oh, yes. So this is our latest turbine, which we call Cypress Platform. So it's a 185-meter rotor blade. It's a 5.3 generator. So when I mentioned that platform must be evolutive, so this turbine has a variable rated power from 4.8 to 5.3 rotor diameter, and this turbine has a blade which is made of 2 pieces. So we have the main part of the blade, and then we have a tip. The tip is about 12 meter. And basically by changing the tip, you can accommodate a different site conditions. And here is the technology changer. So we build one platform, but with changing only one component, you can have a different, your turbine can go to another site, can go to a higher wind speed site or a lower wind speed site. So the tip of the blade can be shorter, but it can also be longer. So basically this turbine, as I mentioned, is generating more, 160% more energy than the one we are selling 5 years ago. And this is, technology has enabled us to do so. I'll go back on this one technology, let's say, changer. It has many. If we think about offshore, which is also another planet, I would say, for turbine, because we have less constraint. Let's say transport is different, noise is different, so we can go bigger and bigger. So GE recently launched the Haliade-X, which is a 12 megawatt turbine, 220 meter rotor diameter. And that's typically the biggest turbine on Earth today. And this was possible because we are using innovative technology. The biggest let's say, innovation in this turbine is the carbon blade. We are using carbon blade that allow, carbon is stiffer than fiberglass, so we can go with a longer blade, easier than fiberglass. So this turbine basically will be our let's say, next platform. Our current platform for offshore is only 5 megawatt and 150 meter. This turbine is 12 megawatt and 220 meter rotor diameter. Probably a word about blades. GE recently acquired LM, which is, let's say, the biggest blade manufacturer. Now LM is part of GE Renewable Energy Group. So we have more, let's say, power on technology and innovation to introduce new features, typically on blades. Technology. Probably my colleague talked about many aspects. Probably all of them talk about two things. I'll not talk about it. It's the up tower electrical system. That's I think there is a major trend to going to install the electrical system up tower. It saves electrical losses. So it makes let's say O&M easier. That's one common to all of us, and of course digitalization. So I think all of us are working on system to better let's say, do asset management, to better do prognostic and diagnostic on cybersecurity. So GE is really, let's say, pushing hard on digitalization. We are building currently a digital ecosystem around our wind farms. But the 4 points, these are purely technology points that my colleague did not mention. It is typically, I'll talk about firstly, as I mentioned, the two-part blade. So this is a completely innovative system. We have a 77-meter blade in two parts. It's 20 tons blade. Basically, I'll do a little bit of maths. It's quite easy. So if we compare our previous platform, which is the 137 rotor diameter, with the new platform, the 158, we have 10 meter different in blades. 10 meter different in blades, we increase it only 2 tons, the weight of the blade. Now, if you go back and if you compare the 130 and the 137, there is 4 meter difference, and we increase the weight by 2.5 tons. So here you see clearly how carbon allow stiffer blades, and how carbon insert allows us to go longer and longer in blade. That's, let's say, the first major technology element for blades. The second is carbon, of course. So we have the joint tip blade and the carbon blade. The carbon blade has been used widely previously in industry, but GE is even making more use now of this carbon for both onshore and offshore application. And this game changer now is allowing us to go to have longer and longer blade. So we said the two pieces blade, we said the material for blades. The third element is, my colleague talked about life extension to 25 years. We are not doing that. We are designing our turbine for 25 years. Means that we can extend the life extension extend the operational life of our turbine over 25 years. We go open 30 years, meaning that if we certify our turbine 25 years, meaning that we are investing more in CapEx to have a more robust turbine with a design assessment of 25 years. This is also a game changer. We've seen that PPAs were more than 20 years. The trend started with 15 years, now it's 20 years, and we are seeing more and more PPAs with 25 years and 30 years. So GE now has turbine with design lifetime of 25 years. And again, this is also a game changer from our perspective. What also I talked about the two pieces blade, the carbon blade, the material, the life extension, and the 4 point that did not mention by my colleague is basically the site-specific application. So, of course, we have a large portfolio of towers, going from 85 meter to hybrid towers. We recently have done 164 meter towers in Germany. But we do site-specific customization of the turbine. Let me give you an example. Recently, we are currently constructing 50 megawatt wind farm in the hottest area of the world, which is in the desert in Oman. So we basically built a customized sand protection system that allows the turbine to work in very harsh conditions of humidity, of sand, and temperature. Going from Oman to Sweden, we are basically now building a huge wind farm in Sweden of 300 megawatt, where conditions are completely the opposite of Oman. So we have very cold conditions, minus 20, minus 30 degrees, but we also have ice. So we have ice mitigation system on these turbine. So basically our engineering, mainly based in Salzburg and in Barcelona, are doing a lot of site application, site customization, and we've seen this really an increased demand of our customer to introduce new technology. And we have done it even for a small volume. So Oman probably was a brilliant case for that. Only 50 megawatt, 13 turbine, but we designed a sand protection system. Of course, we'll leverage from these for the bigger platform, but site application, let's say site-specific application is very important to us. So I'm not sure that I have more slides. Yes, yeah, probably this slide will show you. I forgot about the slide. So the blade size evolution. So our biggest onshore turbine has exactly 77 meter blade, which is the span of the A380, and our offshore turbine, the 107 meter blade, is even bigger than E380 span. So blade is, that blade is a critical element. Blade is the game changer, and we are changing the game with material, but also with technology, having a two-piece blade. This allows easier transportation. So basically, in Europe, we can transport our 158 meter rotor diameter with a simple dolly tracks, as it is not exceeding 80 meter. And the tips are transported by 3 in a simple track. The tip is only 1 ton or 2 tons, sorry, and 11 meter. I believe so that changing blade material, changing blade technology will be, I hope and I believe and I'm sure that will be very useful for the Turkish market. I mean, as far as I know, Turkish wind conditions are ranging from 7.5 to 9 meters per second, so this is perfect for the application space of this turbine. The next plan is to have a bigger rotor diameter, just remove the tip and add a bigger one. So you can increase the rotor diameter up to 10 meters in half a day. Thank you very much. If you have any question.
Thank you very much, Mr. Khaled. Mr. Khaled, kanat.
Okay, thank you very much. Mr. Khaled has provided us some information about the blade technology, recent blades, a game changer, and especially after the acquisition by GE, both in design and in the material side, blade has undergone a significant technological modification. And he referred to a lifetime of 25 years, and also in offshore, the biggest turbine with a perspective of their products. Thank you very much for introducing your products to us. As the last speaker from Servion, Metin Gülgen will be speaking. Metin has been working as the performance engineer of Servion. In the global scale, of course, Servion is a major turbine manufacturer, used to be known as Repower. In terms of creating and improving the market in Turkey, they really have been contributing a lot, and we wish them success in this respect. Yes, Metin. Thank you. Firstly, my name is Metin Gülgen. I am the Senior Plant Performance Engineer for Servion. Today, I will provide you two overviews, one general overview and the other technology overview. Senvion is quite newly positioned in Turkey, so I will give you a general overview. In 2001, with the merger of 5 different countries, Senvion was established. The first turbine was established in MM70. And other than that, in 2006, we have been the first turbine manufacturer providing different turbines. And then in only 10 years of time, we have also managed to introduce an increase in our gigawatts.
In 2014, Senvion, due to some legal cases, has changed their name. And in 2016, by Centerbridge, there was a purchasing. And in the German Frankfurt Stock Exchange, it was quoted. And as of 2018, lastly, 4 megawatts of platforms were introduced into the market. Very briefly, Senvion's portfolio, there are 82 and 100 rotor diameters. And there is a 2.6 megawatts of capacity. We have 35 different offices and manufacturing sites. There are 23 different languages spoken. We have around 4,000 employees. In Turkey, we are located in Istanbul and Ankara. In addition to these offices, we're opening an office in Egypt. We have manufacturing sites in Germany, India, Portugal, and Poland. When it comes to our installed capacity, Senvion's share in the Europe market is very high, but all around the company, we are focusing on engaging into new markets, emerging markets. North America and Middle East markets are our focus. It seems 17 gigawatts of turbines installed worldwide, but there are new turbines at the installation phase. In 2013, in Chile and in Argentina, only in Chile, we received an order of 200 megawatts. And in 2016, by purchasing a turbine company, by making changes, especially in India in the last 2 years, we made sales of 250 megawatts. So they are produced especially for India. Previously, not only for India, but we were giving it to other countries depending on the site characteristics. I will also be showing you some new turbines of 4 megawatts. And we are engaged in projects in the United States and in other countries. And lastly, in Spain with Alsanar, 300 megawatts of capacity is implemented. So we made an agreement of a total of 300 megawatts of capacity. When it comes to our technology and technologic overview, in terms of optimization, Senvion has a modular design. The rotor diameters are root extender and blade extender. We can increase the diameters. Or if, of course, we just look into the wake models in the site and keep it to the minimum levels. For instance, if there is a 150 meters of type restriction, with an 80 meters of tower, we can have higher rotor diameters. In addition, for optimization, we are reducing down BOT costs as much as possible, and we provide optimization, necessary optimization programs. We also have lifetime extension program. Our turbines have a rotor diameter of 140 meters and above. So depending on the site conditions, for instance, BPA is for 20 years. However, your site is class 2. By installing a class 3 turbine, we with an operational lifetime of 20 years, we can use larger rotor dimensions. Or the wind speed is very low in your site. With detailed load assessments, we can increase it to 25 years or 30 years with certificates. And apart from that, when it comes to our portfolio, MM82 to MM152 are among our portfolio. Portfolio may seem very little for Turkey, as mentioned by Abdullah Bey. If countries like France, UK are using these in their previous older projects. 4.2 and 140, 4.2 and 148 are the best models for Turkey, and these are mostly used in Turkey. For offshore, 6.2, 126, 6.3 M152 are among our turbines. 6.2 M123, 126 is smaller for this market. So together with other companies, pioneering companies, we are designing turbines above these levels. What is the future of turbines? I have this slide showing the background of turbines and the future of turbines. In 2000, we were speaking about 1.5 megawatts and with MM70, and in 2003, MM82, 92. Rotor diameters have increased significantly. Since 2008, we started talking about 3 megawatts. Rotor diameters went from 104 to 122 for 3 megawatts, and now we're speaking about 144 or 150, and in a short period of time, there's a shift to 4 megabytes. I believe that in the upcoming future, in the near future, we will see 5 megawatts in the site. For offshore, I believe that we will see about 10 megawatts, and the rotor diameters will be about 200. In 2018, 42M118, 42M140, 42M148 have been introduced into the market. When the wind speed is about 10 meters per second, they are used. For 140, depending on the characteristics of turbulence, we can use it up to class 1 sites. How did we do it? How about the design? We started with and then while passing to 3XM, we have reached higher tower heights, and then with NES system, it is more efficient from electrical terms, and we also transformed into a full transformer. So with rotor diameters about 140 and above, they are used. So for larger rotor diameters and low noise or low voice is there with these devices, with these we can erect higher towers, steel towers. 4XM has similar characteristics. For 2 megawatts in the to MM, and we purchased the company in India, and Actually, even in wind speeds, they can be used, and we can reduce the cost of energy for them.
Evet. Teknoloji olarak hemen bahsedeceğim.
I'll talk about the technology. We have installations we put on small blades. For them, we can reduce the noise level of turbines to very low levels. In series, this is available in series as well. So this makes turbines aerodynamically more efficient. And with anti-icing and de-icing technology, speak about 20 or 25 years for Siemens in terms of lifetime. However, as I mentioned, they are calculated in a site-specific manner. And with our new technology, with lifetime extension, we can increase it by 10 years and we can reach longer lifelines. However, in generic terms, I can say it for Siemens as 20-25 years. Thank you.
Başka sorumuz var mı?
Any other question?
Peki, müsaadenizle Fatih Bey'e bir...
With your permission, an example came to my mind and I want to share it. Fatih Bey, in our service concept, we have made a change for Nordex. Normally,
Türbinler devreye alındıktan
Nordex, after commissioning of the turbines, some maintenance are performed. For instance, type 1 maintenance. By the end of 1 year, you have to do that maintenance. And by the end of 3 years, by the end of 6 years, you have to perform separate maintenance works. In Nordex, the system is changed totally. By the end of the first year, we go to the turbine, we do maintenance. And although we needed to do it 3 years, after 3 years, with the new system, with our new system, we will go into the turbine after 7 or 8 years. I'm speaking about periodic maintenance, changing the oil of the gearbox. Vestas was the same. So by making some changes in the concept, this is different. So you just wanted me to give an example, and I can share that example with you.
katkınız için teşekkür ediyoruz.
Thank you for your contribution. These are the end of our questions.
Is it okay? Oh, no. It's fine?
Yes, fine.
Okay, probably let me add a clarification about life extension. There is two different topics. So you have life extension and you have design lifetime. So if you take this pen is designed for 10 years, I would say, to work normally for 10 years. But because you don't use it a lot, you will use it for 15 years, right? This is operational lifetime extension. But what GE is doing is we are designing this pen for 15 years, right? And so if you don't use it a lot, we can extend the operational lifetime of this pen to 20 or 25 years. So there's two things. I hope it's clear. It's operational lifetime and design lifetime. Exactly. Thank you. Thank you very much.
Thank you very much for your contribution. Çok teşekkür ediyoruz.
Thank you very much for your participation and for your contribution.
2019 yılında önümüzdeki
And we wish to see you in 2019 8th TWEC Congress. Thank you.